In this video, let's practice our decimal operations when dealing with some application word problems together. Real quick before we get started, if you'd like to download a free copy of this blank PDF or look at the annotated answer key PDF, you can find a link to that below. To get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. In number 1, Mrs. Carsdale goes to Conti's, a pizza place, and purchases 7 pizzas that cost $16.04, which tax is included. Let's go ahead and determine the total cost of the pizzas. Alright, so first things first, one of these pizzas is going to cost $16.04. We also know that we're buying 7 of these pizzas and they're all going to be the same. Now we're being asked to find out the total cost of all the pizzas together, so we could go ahead and add the $16.04 7 times, or we could take that $16.04 and go ahead and multiply that by 7. So let's go ahead and do that just because that'll be a lot faster than adding it over and over again. Now when we're multiplying decimals, remember that we can just ignore them and think about them as whole numbers, then think about the decimal places after. So 4 times 7 is going to be 28, carry the 2. 7 times 0 is going to be 0 plus the 2, which is going to be 2. Then we have 7 times 6, which is going to be 42, we'll carry the 4. And then 7 times 1 is going to be 7 plus the 4, which is 11. Now we made the 16.04 100 times bigger, so the product here has to be 100 times smaller. This right here would be the total cost. So we can conclude that the 7 pizzas are going to cost a total of $112.28. Let's try another one together. In number 2, Mr. Lee goes to Chipotle and purchases 3 burritos that each cost $11.37, taxes included. Let's go ahead and determine the total cost of these burritos. Alright, so it looks like we're buying 3 of these burritos, and also each of them is going to be costing this $11.37. So to find the cost, it's very similar to the last example. Let's go ahead and take this $11.37, and we're getting 3 of these, and they're all the same, so let's go ahead and just multiply this by 3. That'll be the quickest way to get our answer. So 7 times 3 is going to be 21, carry the 2. 3 times 3 is 9 plus the 2, which is going to be 11, carry the 1. 3 times 1 is going to be 3 plus the 1 is 4. And then 3 times the 1 is going to be 3. We ignored the 2 decimal places we had in 11.37, so we need to go ahead and put those back. This 34.11 is the total cost. So we can conclude that the 3 burritos cost $34.11 in total. Here's a third example. In this problem, Miss Jager goes to Taqueria and purchases 5 quesadillas that each cost $8.48, where tax is included. Let's go ahead and determine the total cost of all these quesadillas together. Alright, so we do know that we're buying 5 of these same quesadillas, and each of them are going to cost $8.48. So another very similar problem here. Let's go ahead and take this $8.48 and let's go ahead and multiply that by 5 since we're buying 5 of the same item here. So let's go ahead and multiply that out. 5 times 8 is going to be 40. Let's go ahead and carry the 4. 5 times 4 is 20 plus the 4 is 24. Carry the 2. 5 times 8 is going to be 40 plus the 2, so that's going to be 42. So let's go ahead and put the decimal place where it belongs. And so the product here, or the answer to a multiplication problem, is going to be our total cost of the 5 quesadillas. Altogether, the 5 quesadillas are going to cost $42.40. Here's a fourth example. In number 4, Mr. Lanzetta goes to Nomad Pizza and is going to purchase 9 of these pizzas that each cost $18.45 each with tax. Let's go ahead and determine the total cost of the pizzas. Alright, so it looks like we're buying 9 of the same pizzas, very similar to the last examples, and we're also going to be saying that each of these pizzas is going to be $18.45. So if each one is $18.45, and we're going to be buying 9 of them, let's go ahead and just multiply $18.45 times this 9. Alright, so 9 times 5 is going to be 45. Let's go ahead and carry the 4. 9 times 4 is 36, plus the 4 is going to be 40. Let's put the 0 and carry the 4. 9 times 8 is 72, plus the 4 is 76. We'll put the 6 and carry the 7. Then 9 times 1 is going to be 9, plus the 7 is going to be 16. We ignored 2 decimal places earlier, or made it 100 times bigger, so let's go ahead and make our product here 100 times smaller. This product here is going to be our total cost of the pizza. So altogether, 9 of these same pizzas are going to cost $166.05. Here's another example. In number 5, 6 friends are going to be buying tickets to see a Harry Styles concert, and the total cost of all the tickets is going to be $525.90. Assuming that all the tickets are going to be the same price, let's go ahead and determine the cost of one ticket. Alright, so we do know that there are 6 tickets being bought, and we also do know that the total cost was going to be $525.90. So what are we going to do to figure out the price of one of them? Well, that's going to be the total price. Let's go ahead and take this $525.90, and we want to split this total amount of money, 6 different ways to figure out the price of just one ticket here. So let's go ahead and do some division. So does 6 fit into 5? Nope. Does 6 fit into 52? Yes, I think that's going to be 8 times. 8 times 6 is going to be 48. That's as close as we can get. Let's go ahead and make sure our remainder here is less than 6. So let's go ahead and see 52 minus this 48 is going to be 4. That's less than 6, so that's good. Let's go ahead and bring that next number down and just repeat this process here. So 6 going into 45, well, 6 times 7 is 42, which is as close as we can get, I believe. So let's go ahead and put a 7 up here. 7 times 6 is going to be 42. If we go and subtract here, the remainder is 3, which is less than 6. Again, that is a good thing. Let's go ahead and bring this 9 down. This 9 is going to join the 3 to make 39. Let's go ahead and put this decimal in our quotient as well. 6 into this 39, that's going to fit in 6 times, I believe. 6 times 6 is going to be 36, so I think that's as close as we can get. We have a remainder of 3, and that's less than 6, so that's good. Let's go ahead and bring this 0 down and repeat this process one last time. So 6 into 30 hopefully goes in evenly. I think it does. It goes in 5 times. 5 times 6 is going to be exactly 30, so this remainder is 0. This 87.65, or the quotient, is going to be the cost per ticket. So assuming all the tickets were the same price, each one is going to be $87.65. Let's try another. In this example, we have 4 friends that are buying matching hoodies, so they're all going to be the same price. The total cost of the hoodies is going to be $151.36. Let's go ahead and find the cost of one of these hoodies. So this is a similar one to the last example. So we have 4 of these friends, and they're all buying the same hoodie. That's going to be $151.36 each. That's the total price. So let's go ahead and take this total amount of money, and that's for 4 hoodies. So let's go ahead and split that up so that we can find out the price of just one of them. So let's go ahead and divide this by 4. All right, so does 4 fit into 1? Nope. Does 4 fit into 15? Well, I think it fits in not 4 times. 4 times 4 is 16, so let's go with 3. So 3 times 4 is going to be 12. Okay, let's see if this remainder is less than 4. Now 15 minus 12 is going to be 3, which is less than 4, so that's good. So let's keep on going here. Let's bring down the 1 and just repeat the process. So 4 into 31, I think that's going to be 7 times. 7 times 4 is 28. Let's make sure this remainder is less than 4. 31 minus 28 is 3, so that's less than 4. That's good. Let's bring this decimal up here. Just bring that straight up every time. Bring this 3 down, and let's repeat the process. We now have 33, so I know 4 times 7 is going to be 28. 4 times 8 is going to be 32, so let's go with 8 here. 8 times 4 is 32. Let's see if that remainder is less than 4. 33 minus 32 is 1, so that's good. And then bring down the 6. Let's go ahead and hopefully just repeat this one last time. So 4 into 16, that's exactly 4 times, right? 4 times 4 is 16 exactly, and the remainder here is 0. Our quotient here is going to be 37.84. That'll be our answer. All right, let's check out number 7. In number 7, the dimensions of a regular size piece of computer paper in the United States is going to be 11 inches by 8.5 inches. Given that the formula for finding the area of a rectangle is area is equal to length times width, where we have the length is 11 inches and the width is 8.5 inches, or vice versa, it doesn't really matter, determine the area of the regular rectangular size piece of computer paper in square inches. So since we have a formula here, let's just go ahead and define some aspects of this problem. So let's go ahead and call this 11 inches. Let's go ahead and call it the length. And then let's go ahead and take this 8.5 inches. And let's go ahead and call that the width. Right? It doesn't really matter which one is which, just because if you multiply them together, you're going to get the same product either way. So let's go ahead and see if we can find out this area. The area is going to be equal to, all right, A for area, that's equal to. The length is going to be 11. And let's go ahead and multiply that by 8.5. So do 8.5 being multiplied by this 11. All right, so let's go ahead and find the area here. We're gonna do that on the side though. Just go ahead and do the multiplication on the side. So we have 11 multiplied by this 8.5. I'm gonna go ahead and just ignore the decimal places for a moment and just multiply 11 times 85. So 5 times 1 is gonna be 5. 5 times 1 is gonna be 5 again. 8 times 1 is going to be 8, and 8 times 1 is gonna be 8. These are our partial products, and if we add these together, we're going to get a 5. That's 13. Carry the 1. That's going to be a 9. Now keep in mind we did ignore one decimal place, so our product is going to be 10 times too big. So let's go ahead and account for that. So this is going to be 93.5. This product here would tell us the area of this regular piece of paper. So let's go ahead and write that this is going to be 93.5. And so this piece of paper that has dimensions of 11 inches by 8.5 inches is going to have an area of 93.5 square inches. All right, let's check out one final practice problem. In this final example, a tennis court has a length of 23.77 meters and an area of 260.7569 square meters. Given that the formula for finding the area of a rectangle is area equals length times width, determine the width of a tennis court measured in meters. All right, so this length over here of 23.77 meters, let's go ahead and define that as the length. As for the area, we know the area is going to be this 260.7569. That's going to be square meters. That's going to be the area. Let's go and see if we can figure out what the width is going to be, which is our unknown. All right, so just using some variables here, if we know that the area, or capital A, is going to be equal to the length multiplied by the width, or lowercase l times lowercase w, and now if that's true, if the area is equal to the length times the width, then it should hopefully make sense that the width would be equal to the area divided by whatever the length is going to be, right? So let's see if we can use this rearranged version of that formula to figure out what the width is. All right, so the width is going to be equal to, do we know the capital A? Well, that's the area. That's going to be 260.7569. We're going to divide that by the length, which we know is going to be 23.77. So if we can divide these two numbers, we should find the quotient, which is going to be how wide the tennis court is. All right, setting up this long division, and it is going to be rather long, I think, 260.7569. Let's go ahead and take this and divide that by this 23.77. Now, when you're dividing decimals, you want to be careful. We're going to take the dividend and the divisor and make them both 100 times bigger. So let's go ahead and make this 2,377. And as long as we go ahead and make both divisor and the dividend 100 times bigger, then our quotient is going to be the same. So we just don't have to divide by decimal. So keep in mind the decimal is now going to be over here. The answer to this division problem is going to be the same as the answer as what we're getting here. All right, now will this 2,377 fit into 2? Nope. Will it fit into 26? Nope. Will it fit into 260? Also a nope. Will it fit into 2,607? Well, 2607 is definitely bigger. Can we fit two of them in? I don't think so. I think it's just going to be one. So let's go ahead and put a 1 up here above the 7. Okay, so let's go ahead and get rid of these times 100. So hopefully that makes sense why we moved the decimal over. I'm going to move this one as well. So that is no longer there. All right, so if we go ahead and put a 1 on top, 1 times 2377 is just going to be 2377. Again, we couldn't fit two of them because that would be at least over 4,000, right? So 7 minus 7 is going to be 0. 0 minus 7, that's really a 10 minus 7 is going to be a 3. This is really going to be a 5 because we borrowed from it. And so 5 minus 3 is going to be 2. And 2 minus 2 is going to be 0. So let's go ahead and now bring down this 5 and let's just go ahead and repeat the process. Now, will this 2,377, I guess I'm going to get rid of this decimal here since we moved it over. Is this 2,377 going to fit into 2,305? It's a little too big for it. It's not going to fit in a whole number of times. So let's go ahead and put a 0. So 0 times 2377 is 0. If we go ahead and subtract, our remainder is 2305, which is less than 2377. So that's fine. Now let's go ahead and bring this 6 down and see how many times this 2377 fits into 23056, or how many times 2,377 fits into 23,056. Now, if we multiply this by 10, we would just add a 0 onto the end of it. So that would be 23770, which is too big. So let's go ahead and see if we can pick a number smaller than that. I'm thinking of maybe taking this 2377 and multiplying it by 9, since it's pretty close, right? If we multiplied it by 10, we saw how close that was going to be. So 7 times 9 is going to be 63. Let's go ahead and carry the 6. 7 times 9 is 63 again, plus the 6 is going to be 69. Carry the 6. 9 times 3 is going to be 27, plus the 6 is going to be 33. We'll carry the 3. 9 times 2 is 18, plus the 3 is going to be 21. So that's 21,393, and that's definitely under the 23,056. So I'm going to go ahead and put a 9 up here. And the 9 times 2377 we found out was 21,393. Okay, go ahead and subtract and see what the remainder is going to be. All right, if we go ahead and subtract here, 6 minus 3 is going to be 3. 5 minus 9, we're gonna have to borrow here, and we're gonna borrow again. So this is gonna be a 2, this is gonna be a 9, this is gonna be a 15. 15 minus 9 is going to be 6. 9 minus 3 is going to be 6. 2 minus 1 is going to be 1, and 2 minus 2 is 0. So we have 1, 6, 6, 3. And it looks like we have a 9 that we can bring down and hopefully get one more step in here and get an answer. So we're trying to see how many times this 2377 fits into 16639. So let's see, this is about 2,000, all right, a little more than 2,000 going into 16,000. So I think we're gonna be trying something around 7 or 8. If we go ahead and try 8, I think this is gonna be too big, right? Because this is almost like 2,500. It's gonna go in, I don't think 8 times into 16,000. So let's go ahead and try 7 here. If I go ahead and try this 2377 and multiply it by 7, let's see, 7 times 7 is 49, carry the 4. 7 times 7 is 49, plus the 4 is going to be 53, carry the 5. 7 times 3 is 21, plus the 5 is 26, carry the 2. 7 times 2 is 14, plus the 2 is going to be 16. So that's actually really nice because it's exactly 16,639. So let's go and put a 7 up here in our quotient, put our 16639. We can subtract and say that it goes in perfectly, and so we know what our quotient is. This quotient up here of 10.97 or 10 and 97 hundredths is going to be the width of the tennis court. So we can go ahead and say that this W is going to be equal to 10.97. So we know the width of the tennis court is 10.97 meters long. All right, so there you have 8 different practice problems where we went ahead and practiced our decimal operations. Mainly in these 8 problems, we dealt with multiplication and division, just trying to apply them to some different scenarios. So if you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.